Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, time to continue further with Mathematics class 12th. The chapter that we're dealing with is application of derivatives, and it is time to discuss the miscellaneous exercise of chapter 6. Now mind you, all exercises of this particular chapter were very important. Miscellaneous obviously will cover all the concepts, but then herein in this particular chapter, when you talk about the miscellaneous, is miscellaneous the most important? The miscellaneous is good for revision purposes, but then each and every exercise of this chapter is very important. Now there have been very long exercises over here, and we have discussed all those exercises for you. So with this miscellaneous, we'll be winding up this chapter, but then don't forget to watch all other solutions of all other exercises for let us say going through the complete chapter properly, right? So we'll begin with the first question of application of derivatives over here. The first question says, using differentials, find the approximate value of each of the following, okay? And how are we dealing with this? So, if you use differentials, do we know any fourth power of this number, 17 upon 81 or anything close to this? So, 81 power 1 by 4 is very simple, right? This is 3. What is 17 power 1 by 4? Now, I can write this number as, maybe I can imagine this to be some function, right? In terms of functions, I can write it as f of x plus delta x will be equal to f of x. I remember this, plus delta x times f prime x, right? And the important things to note here are function, derivative, x and x plus delta x. So let f of x is equal to this, x power 1 by 4, okay? This is the function. This tells me that f prime x will be equal to what? 1 by 4 times x power minus 3 by 4, which is x power 3 by 4 in the denominator, okay? And x is equal to, let us say, x is something for which we know the fourth root of, okay? And what is that number? Can you please observe that this is very close to 16 upon 81, right? So we know for 16 upon 81, because 16 is 2 power 4, 81 is 3 power 4, we can easily find the fourth root. And x plus delta x will be equal to 17 over 81. The difference, that is delta x, will be simply 1 upon 81. Now as compared to 16 upon 81, 1 upon 81 is pretty small, and we can approximate using this idea, right? Using this formula, let's substitute the values that we have written over here and see where does that take us. F of x plus delta x will be f of 17 by 81 power 1 by 4 is what I get, is approximately equal to fx, which is 16 upon 81 power 1 by 4, plus delta x is 1 upon 81, and what else? F prime x is 1 by 4 times 1 upon x power 3 by 4, which is 16 upon 81 power 3 by 4. Now this 16 upon 81 power 1 by 4 is pretty simple. This 2 power 4, 3 power 4, this becomes 2 by 3, plus 1 upon 81 times 1 upon 4 is also simple. What is this equal to? If you observe, this is 2 power 4, 3 power 4, raised to power 1 by 4 will be 2 and 3. Power 3 will tell me that this is 2 power 3, 3 power 3. Denominator will go over here. This is 3 power 3, which is 27, 81 goes, and this will become 3. This is 2 by 3 plus, what is this? This is 1 upon, okay, 12 times 8. 12 times 8 will be 96. This is approximately equal to this. And what will this value be equal to? 0.666, and maybe up till 4 decimal places, what you can say is this is 0.667 plus what is this? This is 100 upon 96, okay? But for making it 100, let's add a decimal, a 0. This will become 100 upon 96. This is 1 now. Okay, 4 remains. So 4, and after that 40. No, 40 will not suffice. 400 will suffice 4 times. This is what you get. This is approximately equal to what? 7, 4, 11, 1. 1 gets carried. This becomes 7, and 6, 1, 7, and 6. This is 0.6771. That's the final answer, and it can approximate up to 3 decimal places. What you'll get is 0.677. That's the answer for this first part over here. The second part of this question says that we have to find the approximate value of 33 power 1 by 5. Now, how do we deal with this? Power minus 1 by 5, okay? So, power 1 by 5 is something that we have dealt with in the exercises itself. This is power 1 minus 1 by 5. We can deal with this one as well. Let's say f of x plus delta x is what we begin with. This is approximately equal to f of x plus delta x times f prime x. An important thing is to identify function f of x. Let f of x is equal to x power minus 1 by 5. Okay, so this tells me that f prime x will be minus 1 by 5 times x power minus 1 by 5 minus 1, which will be minus 6 by 5. X power minus 6 by 5 is what I'll have over here. This is minus 1 upon 5 x power 6 by 5 is what you'll get, right? What is x? X is something for which we know the power 1 by 5, that is 32, right? X plus delta x can be seen clearly, this is 33. On basis of this, delta x is simply 1, right? And now use this formula along with the values below to derive the value. F of x plus delta x will be 33 power minus 1 by 5. 33 power minus 1 by 5 is equal to 32 power minus 1 by 5 plus delta x, which is 1 times f prime x, which is minus 1 upon 5 times x power 6 by 5. What is that? 32 power 6 by 5 in the denominator. This is equal to 32 is 2 power 5. 2 power 5 power minus 1 by 5 will be 2 power minus 1 plus. This is minus 1 upon 5 times. This is 2 power 5. This becomes 2 power 6 actually. 1 by 2 minus 1 upon 2 power 6 is 64 times 5 is 320. This is 320 in the denominator, and where does that take us further? So this will be 1 by 2 0.5 minus, what is this equal to? 320. So you'll add a decimal, this will become 10, then it will become 100, still not sufficient, then it will become 1000. Okay, now you've added 3 zeros, 1000 upon 320 is 3 times. Okay, 320 times 3 will be 960 and you'll get 40, right? So 40, and if you add 40 as remainder 40, if you add a 0, you'll get 400, which is 31 times. So 0.5 minus 0.0031 is what I'm getting over here, right? One more decimal place, you can go up to one more decimal place, but that's sufficient, I suppose. What you'll get is 400 minus 320 is 80, 800. 800 upon this will be again 2. This is 0.00312 is what you'll get. But let us calculate for this one. This is 9, this is 6, and this will become 9, and 4 minus 0 is 4. 0.4969 is what I get, which is approximately equal to 0.497 as well. You can write it as 0.497 as well. But this is the answer that we're getting in this part over here. Let's talk about the second question that says, show that a function given by fx equal to log x upon x has maximum at x equal to e. Okay. If you have this function fx is equal to log x upon x, obviously the base is the natural base, right? This is what you have. And if you want to find the maximum at x equal to e, we'll have to use the derivative, the concepts of the derivative, right? Where does that take us? This is denominator squared. Denominator times derivative of the numerator, which is 1 upon x minus numerator, times denominator's derivative, which is 1. Okay, this tells me 1 minus log x is what you get, upon x power 2 is what you have over here. This is the derivative, okay. F prime x equals 0 tells me that 1 minus log x equals 0, which tells me log x is equal to 1 or x is equal to e power 1, which is e. This is the critical point, right? And once you find this critical point, there's another one which is 0. But to define this log x, you can see that x will have to be greater than 0, right? We're not supposed to worry about that too much. This is the other point, e. Now between 0 and e, let's pick up 1 for example. Log 1 is 0, 1 minus this will be positive, right? So this will be positive. After that, after e, let's say pick up e square. So this becomes log of e square, which is 2. 1 minus 2 is negative, this will be negative. The function will increase and decrease. And what are we looking at? We are looking at the maximum value. Therefore, maximum occurs at x equal to e. And what is that maximum value? Max value can also be found easily. Max value will be f of e, which is equal to log e upon e. What is that? This is 1 upon e. That's my answer. Max occurs at x equal to e. That's something which we have shown, and the value has also been found. That's the complete proof of this question over here. That's the second question for us. The third question says the two equal sides of an isosceles triangle with fixed base b are decreasing at the rate of 3 centimeter per second. How fast is the area decreasing when the two equal sides are equal to the base? Okay, let's talk about this one. Two equal sides of an isosceles triangle with fixed base B. We have an isosceles triangle like this. These are the two equal sides. Let's call them x, and this is the base B. Decreasing at the rate of 3 centimeter per second. Okay, so this side, let's not call this x, by the way. Okay, per second. Okay, we can call them x. So dx by dt with respect to time is given to be 3 centimeter per second, and this is 3 centimeter per second. But then since it is decreasing, this will be minus 3 centimeter per second. Yes. How fast is the area decreasing? dA by dt is question mark. Okay, when the two equal sides are equal to the base, when x is equal to b, that's the question mark, right? That's the question that we have over here. Okay, so what is the area of this particular, right? For area we need this height. Height will be equal to, this is hypotenuse, x height square plus b by 2 whole square will be x square. So x square minus b square upon 4 is what we are interested in. For the height will be this, right? And for dA by dt we'll have to differentiate, right? Once we write area in terms of x. So area is equal to half base into height. What is that? Half base into height is under root of x square minus b square upon 4. Okay, so this area has been written in terms of x, and now I can differentiate easily. This tells me dA upon dt, differentiating with respect to time, is equal to, this is b by 2, which is a constant. Under root of something will be 1 upon 2 under root of x square minus b square upon 4. And what's the derivative of x square? This is 2x, right? B square upon 4 is a constant. This is what you get. Okay, so where will this take us? In the numerator you have 2bx upon, this is 2 times 2, 4 under root of x square minus b square upon 4 is what I'm getting, right? And we are supposed to find dA by dt for x equal to b. dx by dt is minus 3. By the way, derivative of this dx by dt is also required since you are derivating with respect to time. This is what you need, right? Therefore, the value of dA by dt can be calculated by substituting these few values, right? Let's do that. This is 2b times b upon 4 times under root of b square minus b square upon 4 times, this here is minus 3. You can note that this is minus 3, right? What will this become? This is minus 6b square upon 4 times, what you get is, this is 3b square upon 4 under root of 3 by 2b is what I get over here. Yes? And what else? dA by dt. This is what I get, 4 times 2, this will be 2, and this is 3, and 3 upon root 3 is root 3. So this is minus root 3, b square upon b is this. This is what I get. Oh, we are getting b in the formula. Yes. What about dA? dA is in measured area, is measured in terms of area. Area is measured in centimeter square. This is this. So this was centimeter square per second, and this is the value of, required value of dA by dt. So the area decreases at the rate of root 3b centimeter square per second. How fast is the area decreasing? At the rate of root 3b. So correct answer will be root 3b centimeter square per second. This is the rate of decrease of the area. The person has already mentioned the word decreasing. So not supposed to worry about this minus. This is the final value, and this tells us that the area is decreasing. Yes. So area is decreasing at the rate of root 3b centimeter square per second. That's the correct answer for this question over here. The fourth question says that find the equation of the normal to the curve x square is equal to 4y which passes through the point 1, 2. Equation of normal to the curve this x square is equal to 4y which passes through the point 1, 2. Okay. Now does this point 1, 2 lie on this curve? Please observe, this point 1, 2 does not lie on this curve. This is some random curve. This is y, x square is equal to 4y. And what are we interested in? We are interested in that particular normal which passes through the point 1, 2 over here. We are interested in this normal over here. Now how can we deal with this? Equation of normal to the curve this which passes through the point this. Let's say this is point P and this point is x comma y, let's say, and we'll deal with this point x comma y and write the equation of normal, then maybe pass it through 1, 2 and see where does that take us. So we have one relation between x and y, which what is that? X square will be equal to 4y. Okay, and we can also differentiate x square is equal to 4y to give us 4y prime is equal to 2x, or that tells me that slope y prime will be equal to x by 2. This is something that we know, right? Okay, and the equation in terms of maybe let us say capital X capital Y will be equal to what? Let's say the equation for this point will be capital Y minus small y minus y1 is equal to slope, which is x by 2 times x minus x1. Okay, and instead of this capital X and capital Y, okay, just a minute. This is the equation of tangent. Okay, we are interested in the equation of normal, not the equation of tangent. So for that, for the equation of normal, we'll need the negative reciprocal of this minus 2 upon x is what we have, right? This is the equation of normal. We already have the point, we have the slope, and on the basis of this. And instead of x comma y, if we pass through, let us say if it passes through 1 comma 2, among these coordinates, if it passes through 1 comma 2, what do we get? So this tells me that this will be 2 minus y will be equal to minus 2 upon 1. Just a minute, this is x, this is not 1, and this is 1 minus x, this is what I get, right? So what I'm getting over here is a relation between small x and small y. I have one more relation between small x and small y. I can find those values of x and y, right? With the help of that relation, right? So 2 minus this y is nothing but x square upon 4. Let's eliminate this. Is equal to minus 2 upon x plus 2 upon x into x is 2. This is what you have. This 2 goes with this 2, and what you get is x power 3 is equal to minus minus cancel, this is 8. So the required point is x equal to 2, and with the help of this, the value of y, this point P is, for this point P, x equal to 2, and the value of y will be simply 1. Since you have found this point, then can you write the equation of normal to the curve again? Yes, maybe you can write the equation of normal to the curve easily. Therefore, equation of normal, finally, again we are writing this, will be equal to, for the normal we need two things, the slope and the point. Point is at this particular point what you have, this is 2 comma 1, and the slope, or you already have one point, right? Let's use this point 1 comma 2. So the equation of normal will become y minus 1 is equal to this minus this, 2 minus 1 upon 1 minus 2, that's the slope, times x minus this 2 over here. What does that give me? This is y minus 1 is equal to minus 1 times x minus 2. Can you identify this? Yes. Therefore, y minus 1 is equal to minus x plus 2, which tells me x plus y is equal to 3. That's my correct answer. That's the final equation of the normal through this. Right? That's the fourth question for us. The fifth question says that show that the normal at any point theta to the curve this, x equal to a cos theta plus a times theta times sin theta, y is equal to a sin theta minus a theta cos theta is at a constant distance from the origin. Normal at any point theta to the curve, okay, this is at a constant distance from the origin. Okay, let's try to find the equation of normal and see what is its distance from the origin after that. Okay, so for finding the normal we need the slope of normal, and for that we need the slope of tangent first of all, right? So x is a cos theta plus a theta sin theta, y is a sin theta minus a theta cos theta. Okay, normal at any point theta, we're talking about any general point theta. Okay, let's talk about that. Dy by dx will be equal to dy by d theta upon dx by d theta. Let's find that. What is this equal to? Dy by d theta. Derivative with respect to theta will be a cos theta minus a cos theta and minus a theta times cos theta derivative is minus sin theta. This is what you get, right? Here I am applying the product rule over here. A times cos theta, theta derivative is this 1, and then a theta constant and cos theta derivative is minus sin theta. Similarly for this, dx by d theta, a cos theta plus a sin theta is what I get. Just a minute. What I get over here is a sin theta and minus what you get is a theta, sorry, plus a theta cos theta is what I get, right? Please note this carefully. This is a cos theta, the derivative will be minus sin theta. We are differentiating, yes, don't make a mistake over here. This is minus sin theta, the derivative is minus sin theta. And here a times sin theta, theta's derivative is 1. A theta, the derivative of sine theta is cos theta. Okay, that's interesting. This goes, this goes, this goes, this goes. Yes. A, theta, theta also gets cancelled, and this is sine theta upon cos theta. This actually becomes tan theta. Oh, amazing. The slope of this particular curve is nothing but tan theta, right? Slope is tan theta, and normal at any point theta is supposed to be found. For any point theta, let's pick up this theta, right? This is any point, and therefore equation of normal. For normal, what do I need? Y minus this a sine theta plus a theta cos theta. This is y is equal to slope. Slope is negative reciprocal of this. Tan theta reciprocal is cot theta, with a minus will become minus cot theta times x minus that x. A cos theta plus a theta sin theta. Okay, and it becomes, with the extra minus, since we are subtracting, this becomes minus a theta sin theta. This is the equation of normal. Okay, we can find the distance of this normal from the origin very easily. What do we need for that? We need this important result. For any line having equation ax plus by plus c equal to 0, the distance from any point p x1 comma y1 can be found by this formula. D is equal to ax1 plus by1 plus c upon under root of a square plus b square. This is the result that we should remember, right? That's the modulus. At the end, we have taken a modulus. If x1 y1 is 0, this becomes 0 plus c upon under root of a square plus b square is what we are interested in. So let's write in the form of this ax plus by plus c. And how will we be able to do that? This cot theta is nothing but cos upon sine. Let's bring this sine over here. This becomes sine theta times y minus a sine square theta plus a theta cos theta sine theta. Okay. In the right hand side, this is minus cos theta in the numerator. Minus x cos theta is what we'll get. And minus will become plus a cos square theta over here. And minus will become plus cos theta, a theta cos theta sin theta is what I get. Okay. Do you see that some terms get cancelled over here? A theta cos theta sin theta, a theta cos theta sin theta on the LHS and RHS gets cancelled. Let's bring everything on the left hand side. X cos theta plus y sin theta and is equal to a cos square theta plus a sin square theta. A times cos square theta plus sin square theta is again 1. This is the equation of normal. This is the equation of normal, and distance from origin will be equal to 0 minus a x1 plus b y1 plus c. This is what you get. 0 plus 0, 0 cos theta, 0 cos sin theta minus this upon under root of cos square theta plus sin square theta, coefficients. Right? Modulus, this will be equal to a. Nothing but a. And yes, this is a constant. This is constant, hence proved. That's the complete proof of this question over here. That's the 5th question for us, right? The 6th question says that find the intervals in which the function f given by fx equals 4 sin x minus 2x minus x cos x over 2 plus cos x is increasing or decreasing. Okay, we have this function fx, and do you observe that this x is creating a lot of problems, but then it will be simplified. If you see 2 plus cos x over there, you take out x common, this is 4 sin x minus, you take out x common, this becomes 2 plus cos x, and in the denominator as well you have 2 plus cos x. Okay, so this simplifies into 4 sin x over 2 plus cos x minus x. This simplifies into this. Okay, I can find the derivative so that I can check increasing and decreasing nature easily. The derivative will be denominator squared for this first term, 2 plus cos x and its square. Denominator times derivative of numerator. What is that? 2 plus cos x times 4 sin x, derivative is 4 cos x minus 4 sin x as it is, and times the derivative of denominator. What is that? 2 derivative is 0, cos x, the derivative is minus sin x. This is what you get. And x, the derivative is 1. Okay, what else? This is 8 cos x plus 4 cos square x plus 4 sin square x. Okay, 8 cos x plus 4 cos square x, 4 sin square x will become 4 only upon, this is 2 plus cos x and its square minus 1. Will this simplify further? Yes, this should simplify further. In the denominator you will have 2 plus cos x and its square. In the numerator you will have 8 cos x plus 4 minus this square term. What is that? 4 minus cos square x minus 4 cos x is what you have. Okay, 4 goes with 4 and this further simplifies to 8 minus 4 is 4 cos x minus cos square x. So you can take out a cos x common and you are left with 4 minus cos x, and this is 2 plus cos x whole square. For analyzing the nature, we need the critical points, or simply see that this is positive. This here cos x lies between -1 to 1. Yes, so 4 minus cos x will lie between 3 and 5. This is always positive, this is always positive. The sign of cos x will decide the nature of function increasing or decreasing. Now the sign of cos x can be identified with the help of the graph of cos x. Okay, the graph of cos x looks like this, and here this point is pi by 2, this point is 3 pi by 2, this point is 2 pi, right? And if we talk about the principal values, this is the interval that we'll be looking forward to, 0 to 2 pi. Let's talk about this interval. And therefore f prime x is greater than 0 when cos x is greater than 0. That's what I can identify. Or we can say that fx is increasing for x belongs to 0 comma pi by 2 and x belongs to 3 pi by 2 comma 2 pi. Mind you, these are just the principal values. These are just the principal values. If you want a general value, what you can do is simply add a 2n pi over here, add a 2n pi over here, add a 2n pi, add a 2n pi over here. Similarly, fx is decreasing for x belongs to this interval pi by 2 to 3 pi by 2. And I can find general values as well by adding a 2n pi and a 2n pi over here and here. That's the complete solution for this question over here, the 6th question. The 7th question says, find the intervals in which the function f given by fx equals x power 3 plus 1 upon x power 3 is increasing or decreasing. Okay, we'll deal with this f of x. Okay, the function f of x is equal to x power 3 plus 1 upon x power 3. Okay, this tells me that f prime x will be equal to 3x square minus 3 upon x power 4. This is what you get, right? Please note this. This is what you get, f prime x. Okay, and let's take the LCM x power 4. Let's take a 3 common outside. This becomes x power 6 minus 1, right? Okay, x power 6 minus 1 can be factorized as x power 3 plus 1, x power 3 minus 1, and that will give me x minus 1, x plus 1. Two critical points, minus 1 and plus 1. Okay, the derivative can be analyzed very easily, and what we can see is for values greater than 1 this is positive, for values between these two this is another critical point is 0 as well, because the derivative is not existing. This is minus, okay, here also it is minus and here it is plus. So the function will be increasing over here, decreasing and decreasing, and then increasing over here in this interval. Intervals in which the function f given by this is increasing, first part. For increasing, the intervals will be minus infinity comma minus 1 and 1 comma infinity. Those are the intervals for increasing function, increasing nature. For decreasing you'll have minus 1 comma 0 and 0 comma 1. Those are the intervals in which the function is decreasing. That's what you can observe. X is not equal to 0. Take care of that, right? Okay, and you're good to go. That's a complete solution of this question. The 8th question says, find the maximum area of an isosceles triangle inscribed in the ellipse this with its vertex at one end of the major axis. Okay, we are interested in the maximum area of an isosceles triangle inscribed in the ellipse this. This is the ellipse, and one end of the isosceles triangle is vertex at one end of the major axis. So this is the isosceles triangle. This is what it will look like, right? This is what it will look like. This is vertex A, this coordinate is A comma 0, let's say. This is B and C for the triangle, and the coordinates of this B and C, as you can observe, the triangle is isosceles, this length is equal to this length. So this BC line will be parallel to the y-axis. This is something which you can observe, right? Okay, maximum area of an isosceles triangle. When we are interested in the maximum area, let's try to identify the coordinates of B and C somehow. Let's assume them something. So B is lying on this ellipse. B can be taken as A cos theta comma B sin theta. Okay, And this here, because of symmetricity, will become a cos theta, comma, minus of b sin theta. This is what you'll have, right? Parametric coordinates of any points on an ellipse. For ellipse, x square by a square plus y square by b square is equal to 1. I have taken a point on the ellipse as this, and corresponding point becomes this. Now we can talk about the area of this isosceles triangle in terms of theta. Yes, maximum area. Okay, area of isosceles triangle will be equal to half times this base length BC times the height. Height will be this. If this is D, height will be this AD. Okay, half is okay. Base length BC will be y coordinate added. B sin theta will be 2b sin theta times AD. AD is this total from OA. If you find this OA, this is A, and correspondingly if you find this OD. So first you find OA, that is A, and OD is A cos theta. So this is A minus A cos theta. Although it could have been if A cos theta shifts that side, it would have been A plus A cos theta. But in that case, A cos theta would have been negative, right? So let us write it in this manner only, and this is the area. This 2 goes, this is B and A come out, sin theta times 1 minus cos theta is what I have in terms of theta. We can differentiate and find the maximum area easily. So dA by d theta is next what we are interested in. AB times sin theta, and the derivative of 1 minus cos theta will be plus sin theta. Okay. What about the other thing? This is plus AB times 1 minus cos theta, and the derivative of sin theta is cos theta. This is what you get. Let's simplify this. AB comes out common. This becomes sin square theta, and plus cos theta minus cos square theta is what I get. Okay, very interesting. And where does that take us? So sin square theta can be written as, by after differentiation we need to find the value of theta, or we can find the value of cos theta by maybe simplifying this. This is AB, this is cos theta. Okay, 1 minus cos square theta will become 1 plus cos theta minus 2 cos square theta. This is what you'll get, right? This is what you'll get. And can I factorize this expression? Yes. Can I factorize this? I can factorize this easily. This is 1 minus cos theta, and this is 1 minus is it 2 cos square theta? 1 plus 2 cos theta. Check this out. This is 1 plus 2 cos theta minus cos theta is this, and minus 2 cos square theta. That's what you get, right? That's the complete derivative of theta. From here I get cos theta equal to 1, or cos theta is equal to minus 1 by 2. If cos theta is equal to 1, this becomes A. Okay, so B and C will fall over A, and in that case I'll get a point triangle which is having area 0. So that will be minimum value, and the other value will obviously give me the maximum value. Cos theta is equal to minus 1 by 2. You can observe cos theta will be somewhere here, and therefore the points B and C will shift over there, and that will give me the maximum area. That's what I can observe. So A max implies cos theta will be equal to minus 1 by 2. By equating it to 0, I get cos theta is equal to 1 or minus 1 by 2. Now this is not acceptable, this is acceptable, as I can clearly observe by general analysis over there. So A max appears for cos theta is equal to minus 1 by 2, and we are supposed to find the maximum area. We are supposed to find that maximum area. Okay, this gives me A max is equal to this AB times, what is sin theta? Cos theta is minus half, so sin theta will be equal to root 3 by 2. And 1 minus half will become 1 plus 1 by 2, which is 3 by 2. So this becomes 3 root 3 by 4 AB, and yes, that is my answer for maximum area for this triangle over here. This isosceles triangle inscribed in the ellipse. That's the complete solution of this question. The ninth question says, a tank with rectangular base and rectangular sides open at the top is to be constructed so that its depth is 2 meter and volume is 8 meter cube. Okay, tank with rectangular base and rectangular sides. Okay, we have a tank in this way. Let's say this is the tank, and this is a tank, let's say. Okay, open at the top is to be constructed so that its depth is 2 meter. Depth is 2 meter and volume is 8 meter cube. Okay, depth is fixed, volume is 8 meter cube. Okay, volume comma V is 8 meter cube. Depth is fixed. If building of tank costs rupees 70 per square meters for the base and rupees 45 per square meter for sides. Okay, what is the cost of least expensive tank? So for least expensive tank, what do we have? We'll have to reduce the cost, right? So how much will be the cost? Let's analyze that. If this length is x, this length is y, this width is y over here, what we'll have is the first thing which is known as x times y times 2 is equal to 8, which tells me that xy, the product is equal to 4. That's one thing that we know, right? And 70 per square meters, 45 per square meters, everything is meters, length is in meters, so we can deal with that very easily. Okay, cost of constructing the tank for the base, cost will be 70 per square meter for the base, okay, and base area is x into y. So x into y into 70, x into y meter square, 70 per square meters is this much rupees, right? Cost in rupees will be this. Next, plus for the sides, what do we have? Y times 2, x times 2, y times 2 and x times 2 at the back is the net area of the sides, and it costs rupees 45 per square meter for the sides, okay? So you have 2x plus 2y times 2, okay? X plus y times 2 is actually 4 times x plus y, 4 times x plus y, considering the depth as well, and the cost is 45 rupees. Okay, so this tells me that 70 times xy plus 90 times x plus y is the cost that we are interested in, and we are supposed to minimize this cost, okay? And there are two variables involved. We can eliminate one of the variables with the help of this result. Let's say cost is equal to 70 times xy. What is xy? 4 plus 90 times x plus y is nothing but 4 upon x. Okay, this is 280 plus 90 times x plus 4 upon x. Once you have this cost in terms of x, I can differentiate. This is 0 plus 90 times 1 minus 4 upon x square. Okay. Yes. And this will simplify into 90 upon x square times x square minus 4, which is x plus 2, x minus 2. The value of x, as you can clearly observe, cannot be negative. So we'll have to analyze beyond 0. The very critical points are 2, minus 2 and 0 for that matter, right? So beyond 2, this is all positive. Before 2, this is negative. The value decreases and the value increases like this. The cost function decreases and increases. So minimum cost will be attained when x is equal to 2. Minimum cost will be attained when x is equal to 2. Therefore, x equal to 2 implies minimum cost. Okay. X equal to 2 will also tell me the value of y. Y equals 2 as well. Therefore, C minimum, cost minimum is equal to what? Cost minimum is this function over here. I can use that. This is 280 plus 90 times 2 plus 4 by 2, which is 2 plus 2 is 4. 4 times 90 is 360. 360 plus 280. 360 plus 280 will be 640, right? Yes, 360 plus 280 will be 640 rupees. This is the minimum cost. Cost is equal to 640 rupees for the construction of all of this. Let's check the calculations a bit. This seems to be the answer, but what do we have? 640, 280, 19 times 4 is 360. This is okay. This 2 seems okay. But if you observe, this is 4 times 45 is not actually 90. This is actually equal to 180. This should have been 180. Please make that correction over here. If this is 180, will that make a difference over here? No, this is 180, this is 180, this is 180. This is all of these are 180. And what will that impact? This is 180 again. This will not impact anything else except for this 180 and this answer. This answer will have to be modified because 4 times 45 is not 90, that is 180, right? Correct that. 180 times 4, 180 times 4 will be 720 and 280 will imply that this is 1000 rupees, and yes, that is the correct answer for this question over here. Please make that correction. Right, that is all in this question. The 10th question says the sum of the perimeter of a circle and square is k. Okay, sum of perimeter of a circle and a square is k, where k is some constant. Okay, perimeter of a circle and perimeter of a square. We are interested in the sum of these perimeters. Let's draw the square and let's draw the circle. Okay, perimeter P1, perimeter P2, and it is given that P1 plus P2 is fixed, which is k. Okay, if the side length is a, if this radius is r, I am aware of this. I am aware of the perimeters. P1 is 4a, P2 is 2 pi r is what I am interested in. So this tells me that 4a plus 2 pi r is equal to k. Now this is something that I know. Next, prove that the sum of their areas is least when the side of square is double the radius. So we want some relation between side and radius when the sum of their areas is least. So this is a1. a1 is a square. Okay. This is a square for us. A2 is pi r square. And we want to minimize this area. Area is sum of these two. A1 plus A2. What is that? A square plus pi r square. Let's try to minimize this. Okay, there are two variables involved in this, a and r, and we can eliminate one of these variables using this k somehow. So let's eliminate that. And which one is easier to eliminate? Both are similar for that matter. Pi r square, let it remain as it is. Let this pi r square remain as it is. Plus a square. A can be written as, this a can be written easily as, a is k minus 2 pi r upon 4. K minus 2 pi r upon 4, and its square is important, right? This is a square. So capital A, that's the area, is equal to pi r square plus this whole thing. And therefore we know the area in terms of radius r. And we can now minimize this. Some of this areas is least, right? So we can think about minimizing, but pi r square plus k minus 2 pi r upon 4 and its square. Let's find the derivative of this r. What is that? Derivative with respect to r maybe, area. This is 2 pi r plus 2 times k minus 2 pi r upon 4. And what's the derivative of this minus 2 pi r upon 4? This is minus 2 pi upon 4. K is a constant, right? This is what you get. Okay, that simplifies to what? You have this goes 2 and this 2 goes with this 2. This equals 2 pi r remains as it is, and what is this equal to? This is a minus pi by 4 times k minus 2 pi r is what I get, right? This is what I get. Is that okay? Yes, that seems okay. And this 2 pi r with a minus and a pi by 4 with a minus will actually become pi square by 2 with a plus. Okay, let's write that, simplify that. This is r times 2 pi and plus, what is this, pi square by 2, okay, pretty interesting, and minus pi by 4, k is what I get, okay. And once you differentiate this further, double derivative will be this quantity, which is a positive quantity. So this will be a minima, this will give me, therefore a minimum at r equals this quantity, pi by 4 k upon this 2 pi plus pi square by 2, pretty interesting. This is the value of r, okay. And what did we start with proving? We wanted to prove that the sum of their areas is least when the side of the square is double the radius of the circle. We wanted to prove that a is equal to 2r. So r has been obtained, okay. And what else? Can we also deal with a? Yes, we can find a. This tells me that r is equal to pi k upon 4 goes below. This is 8 pi plus 4 by 2, which is 2 pi square. Okay, you can cancel a factor of pi. This tells me that r is equal to, you can cancel pi, k upon 8 plus 2 pi. This is r. And correspondingly, can you find a? Yes, a can be found with the help of this. K minus 2 pi r upon 4. K minus 2 pi r upon 4. K upon 4 minus 2 pi upon 4, which is pi by 2 times r. R is k upon 8 plus 2 pi. This is what you get, right? Can I simplify this somehow? Yes, I can simplify that. What will this give me? A equals, let's simplify this further, and the LCM will be 8 plus 2 by 2 and 4. The LCM will be 4 times 8 plus 2 pi, okay, and this will become 4 is already there. 8k plus 2 pi k minus pi k is what you get, right? Please observe, this is what you get. Minus pi k, no, minus 2 pi k is what you get. So 2 pi k gets cancelled because this is a 2, and 8k upon 4, this will be actually 8 upon 4 will become 2k upon 8 plus 2 pi. Okay, that's pretty interesting. A is equal to 2k upon 8 plus 2 pi. This is k upon 8 plus 2 pi. So yes, R is equal to 2a. This is what you get. Oh, ulta. Just the opposite, not this. A is equal to 2r. Yes, just the opposite. This is what you have. 2 times r is equal to a. That's what you have. Side of the square is double the radius of the circle, hence proved. Yes, you can write these results, and that's okay. That's a complete solution of this question. You can take a look at this. This 10th question. The 11th question says a window is in the form of a rectangle surmounted by a semicircular opening. Okay. The total perimeter of the window is 10 meter in a rectangle and surmounted by a semicircular opening. This is a semicircular opening, let us say. Total perimeter of the window is 10 meter. Find the dimensions of the window to admit maximum light through the whole opening. Now, maximum light will open if the area is maximum, right? Perimeter is given and area has to be maximized. That's the important thing. Okay, total perimeter is 10 meter. Perimeter is given to be 10 meter. And we want to maximize the area so that maximum light enters through the opening. Okay, there's only one unit of length measured, and that is meter. We'll use that. Okay, let us assume this is x, this is y. So this will be radius of this circle, and you can observe that r will be equal to x by 2. That is one thing, right? Perimeter is equal to 10 implies that perimeter 10 is equal to this x plus y plus this y. Perimeter will be the boundary only. We don't need this x over here. X plus y plus this y, this x, this y, and this semicircle. Semicircle will be pi r. And pi r. Okay, let's write pi r only. This is one of the relations, right? Okay. And radius is simply x by 2, right? Radius is simply x by 2. So I can write pi x by 2. This is 2y plus x plus pi x by 2. Okay, you have a relation between x and y. And what about the area? Area is simple. Area is this xy is the rectangular region plus half of pi r square is what you have over here, right? And we can eliminate this r again using that x. And what do we get over here? Therefore, area is equal to xy plus half into pi r square. Pi times x square by 4 is what I get. Now you have x and y, two variables involved over here in the area. You have to eliminate one of the variables using this 10. So this tells me area in terms of x can be found. X times y will be equal to 10 minus x minus pi x by 2 upon 2. Whole divided by 2 plus this is pi x square by 8. Now we have complete area in terms of x, and we can differentiate this with respect to x to get the minimum and maximum values, whatever is required, right? So maximum light will imply maximum area is required. So this is, okay, this becomes 10x by 2, which is 5x, the derivative is 5, minus x square by 2, minus x square by 2, the derivative will be x square, the derivative will be minus 2x by 2, which is minus x, and this is minus pi by 4 and times x square derivative is 2x again. This is plus 2 pi x by 8. That's what you have, right? So you have 2 pi x by 8, you have 2 pi x by 4 with a minus. Okay, so this becomes 4 pi x by 8, and this is 2 pi x by 8 with a plus 5 minus x minus 2 pi x by 8 is what I get. This is what I'm getting, right? Okay, can I find the value of x easily? Yes, this is 5 minus x times 1 plus 2 pi by 8. If I take x common, this is what I get. On double differentiation, you will observe that this becomes minus of 1 plus 2 pi by 8, which is negative. So this is the kind of shape that you'll get. And yes, x equals, if this is equal to 0, 5 upon 1 plus 2 pi by 8 gives me, this implies a max, right? Single derivative equal to 0 is the critical point. At the critical point, you are getting a maximum. So x area maximum will be for x equals this. Okay, find the dimensions of the window to admit maximum light through the whole opening. Okay. So dimensions of the window would imply that you need the width of the rectangular part, you need the height of that rectangular part, and corresponding to it, you'll have a semicircular over there. So x is obtained. Okay. Right, it's like x is equal to 40 over 2 pi plus 8, or you can say that x is equal to 20 upon pi plus 4 meters. This is x. That's the width. What about y? Y can be obtained with the help of this result. Yes, we have used that over there. So y will be equal to, let's calculate y with the help of all this information. Okay, x is already there, 20 upon pi plus 4. Yes, 10 is equal to 2y plus, let's take the LCM, 2 plus pi upon 2, x times 2 plus pi upon 2 is what I have. Yes, 2 plus pi upon 2. And what else? This tells me that 2y will be equal to 10 minus 2 plus pi upon 2 times x. X is 20 upon pi plus 4. Let's simplify this further. What is this simplifying into? We have this goes 10 times, and what do we have in the denominator is pi plus 4. In the numerator this is 10, and you have pi plus 4 minus 2 minus pi, which is 2, and this becomes 20 upon pi plus 4 as well. So this is 2y, and y will become actually 10 times this. So let's get rid of this 20 and let's write it 10 over there. That will be my final answer for this question over here. This is 10 upon this in terms of meter. That's the final answer for this. X equals this, y is equal to this. Those are the dimensions of the window to admit maximum light through the whole opening, x and y. X is this width, okay, which is the diameter of the semicircular opening as well, and the height of this particular rectangular part will be 10 upon pi plus 4. That's the final answer for this question over here. Let's discuss this 12th question next. The question says a point on the hypotenuse of a triangle is at a distance a and b from the sides of the triangle. Okay, from the sides of the triangle, this point is at a distance a and b. As you can clearly see, this is a point on the hypotenuse, let's say, and it is at some distance a and some distance b from here. Let's say this is the x-axis, this distance is, for example, let's say this is y-axis, this is a and b. This is similar to the coordinate plane, by the way, and we can solve this question using concepts of coordinate geometry as well. Okay, can we do that? Yes, this becomes x-axis, this becomes a y-axis. We'll have to involve the angles, by the way, right? Because these lengths are given and the length of the hypotenuse can be dealt with in terms of AB, and maybe with the help of this theta, I can work out with this theta, right? If this is theta, this angle is also theta, right? This is perpendicular, this is perpendicular, this is theta, this is also theta. What do we get? Let's say if this is A, this is B, then I can easily find this length. PA sin theta will be B, and this further PA will be equal to, PA sin theta will be B, or PA will be equal to B cosec theta. That's what I get. Okay, what about PB? PB cos theta is this, or PB is equal to A sec theta. That's what I get, right? Okay, and now I can write the length of hypotenuse easily, right? With the concept, some concepts which I have developed in coordinate geometry, I can write PA plus PB, that's the hypotenuse, AB is equal to PA plus PB, and this is equal to A sec theta plus B cosec theta. And now the thing that remains is simple differentiation in terms of theta and maybe get the value of theta. So derivative AB of with respect to theta, what is that? A times sec theta tan theta minus B cosec theta cot theta. This is what you have. So this is equal to what? This implies that d by d theta of this hypotenuse length AB is equal to what? Okay, let's see this. This is A sin theta upon cos square theta. Okay, and this is minus B sin theta upon cos square theta. Just a minute, this becomes cos theta upon sin square theta. And this tells me if you take the LCM, this is sin square theta, cos square theta, this becomes A sin power 3 theta minus B cos power 3 theta. What we can do is we can convert this in terms of tan, maybe dividing by B sin A sin cube theta. We can divide by A sin cube theta, A cos cube theta, sorry, A and cos cube theta, and what I'll get is divide numerator and denominator by this, or basically we multiply and divide by this. Yes, yes. So this will become tan cube theta minus b upon a, right? A cos cube theta is what we have done, right? This is what you have done in the numerator, and we multiply by a cos cube theta. What will remain is a and cos cube theta, and denominator will be sine square theta. This is cos cube theta upon cos square theta will be simply cos theta in the numerator. This is what you get. If you observe, I can easily equate this to 0 and get a value of tan theta, for which we'll get a critical point basically, yes, for theta. Otherwise, for cos theta and sine theta, if you think about the extremes, cos theta equal to 0, sine theta equal to 0, what you'll get is a very small triangle or a very big triangle. Basically, very small triangle in this way, or theta becomes 90 degree in the other way, and in this cases both the extremes are there. That is the side lengths. Side lengths will be actually, what you'll observe is side lengths will be, can you observe that side length, the hypotenuse length, if theta becomes very, very small, this hypotenuse will be very, very long over here, right? If theta becomes very, very large, this hypotenuse will be very, very large again over here, right? This is what you'll get, since theta, the hypotenuse has to pass through these points. So those are two extremes which you are not dealing with. We're dealing with the middle one, and that gives me the minimum length of the hypotenuse. Therefore, AB minimum implies tan theta is equal to b upon a power 1 by 3. That's what I'm interested in, right? Tan theta equals to this, and if tan theta equals to this for AB minimum, the minimum length of AB will be equal to what? This is AB, we already know, this is a sec theta plus b cosec theta. Yes, a sec theta plus b cosec theta, and I can easily find the value of sec theta. What is sec theta equal to? Now sec theta is under root of 1 plus tan square theta, and under root of 1 plus tan square theta, what will that give me? Okay, let's multiply them. A times under root of 1 plus tan square theta, or can we draw the diagram triangle and then maybe solve this? Yes, instead of applying the formula, yes, we can do that as well. Let's draw the diagram triangle. If this is theta, then this is b power 1 by 3, this is a power 1 by 3, and this is theta over here, this is the hypotenuse, right? We can use that, and this will be a times that hypotenuse, maybe that small hypotenuse, let's call this h, upon sec theta will be equal to hypotenuse upon b base a power 1 by 3 plus b times h upon b power 1 by 3 is what you get. This is a power 2 by 3, h will come out common, a power 2 by 3 plus b power 2 by 3. What is this h actually? This h is nothing but a power 2 by 3 plus b power 2 by 3 under root. Okay. So under root of this whole thing and multiplied with this whole thing will be a power 2 by 3 plus b power 2 by 3 raised to power 3 by 2. And yes, this is what we wanted to prove, right? That's the complete proof of this question for you. That's the 12th question for us, right? That's the complete solution of this 12th question. Very interesting steps over here which you need to take care of. You could have moved in the direction of coordinate geometry as well, but still we would need that theta for minimizing the value of length of the hypotenuse, right? That's the complete solution for this question.